Thank you. Welcome to Deep Dive. My name is Margaret Holm. I'm a member of First Things First Okanagan. And at the controls is Lori Goldman. Sue Kirschman will be introducing our speaker. I just want to welcome you to Deep Dive. It's a monthly online seminar that we have. We're trying to find solutions to the climate situation for ourselves and for our communities. So here in the Okanagan, we live on the unceded traditional territory of the Syilx Okanagan, and we value their Indigenous ecological knowledge and worldviews. And we often try to give the audience an opportunity to deepen their knowledge of Syilx culture and current issues. This Saturday in Penticton, we have a very interesting opportunity to participate in the blanket exercise. It takes 2.5 hours. It's going to be at St. Andrew's Church, as you can see there, between 9 and 11:30 a.m. It literally walks you through the shared history of Indigenous and non-Indigenous people in Canada, from pre-contact through to treaty making and colonization. You're actively involved in stepping on blankets that represent the land of Canada, and you're invited to take the role of First Nations, Inuit, and Métis people. And it sort of engages you physically as you walk through history through this blanket exercise. And the last hour is spent reflecting on the experience with the other people that are participating. So it's facilitated by Barbara Jagondix of Kelowna Friendship Society. You're asked to pre-register and make a donation, and there'll be a link put into the chat, and you'll also get that link in the email. So that's this Saturday from 9 to 11:30, an opportunity to deepen your knowledge of the history of and relationship between Indigenous and non-Indigenous people in Canada. I'd like to the speaker for this evening. Thank you.
Great, thanks, Margaret. Hi, everybody. Welcome this evening. Lori, if you could just pop up that graph. I just wanted to start by talking about fossil fuels in buildings. Contributes about 12% of emissions in fossil fuels in buildings, is either the biggest or second biggest source of carbon pollution. In Penticton and other interior communities, buildings produce roughly 1/3 of all the emissions, while in Vancouver it is more, it's over half, of course, because it's much denser. And you can take that down now, thanks, Larry. While newly built sustainable dwellings often grab the headlines, it is the buildings that are currently standing and that will be standing for many years to come that are some of the lowest hanging fruit. So at this point, I'd like to welcome Brian Rippey, and thanks so much, Brian, for presenting to us tonight. I will turn it over to you now.
Well, thanks for that introduction, Sue. I should have shortened that biography because we don't have a lot of time tonight. At any rate, can you guys go ahead and see my screen?
Yes. Yes, it's there. Yeah, looks great.
Excellent. All right. Okay, well, let's go ahead and let's get into it. I'm just going to make some quick adjustments here. There we go. Okay, everybody, welcome. And thanks for everybody that registered. Wow, that's a lot of people. And I went over some of the comments when you registered, and it seems like there are a couple of repeating themes here. Number one with the bullet is cost, which is not a surprise. And I hope I do that some justice. And then number two is sort of the process. You know, it can seem kind of overwhelming. How do we get started with something like a retrofit, just in and of itself, let alone something like a deep energy retrofit? I guess that's probably maybe a good place to start is what is a deep energy retrofit? Some of you may be familiar with that term. Some of you have maybe never heard of it. But essentially what it is taking an existing building and reducing its energy use by more than half. So that 50% target. the concepts of deep energy retrofits have been around for some time. We're seeing more and more interest in it, especially given the need to reduce our carbon emissions and other things related to that I'll talk about tonight. Again, if I go too fast, please let me know, because there's a lot of material to cover. And I just want to say up front that this particular project was my house. I did it as part of a research project as well. It's, what you have in your house or your strata, your needs will be different, but I hope that there are some takeaways here. And that's the thing about deep energy retrofit, is they're not standardized. There's no cookie cutter necessarily format to them. So again, I'm hoping to be able to answer some of those questions. And if you have some more, hopefully I'll be able to have some follow-up with that. But nonetheless, let's go ahead and get into it. Starting with the background, we purchased this house, my family, in 2016, and really fell in love with the area that it's in. The house was very typical of a British Columbia house built in the 50s and even 60s, with a traditional rectangular footprint and hip roof with a basement. The house has seen several minor renovations over the years, as buildings see. And when we took occupancy, it had R12 walls, R20 attic. Eventually, I did quite a bit of air sealing myself, and it ended up at around 4 air changes per hour. And if you're not familiar with that metric, that's just basically determining how many times that house's volume of air turns over within 1 hour. And actually, for an older home, 4 air changes per hour is not too bad. The house had new windows put in the early 2000s. So they weren't the original windows. They were double pane vinyl windows. And then for heating, cooling, and cooking, we used had gas appliances. And again, like I mentioned, there were several minor improvements made over the years. One thing to note about this particular location here in Penticton is there's 4 unmaintained city park lots next to us. It's always been a fire concern of ours. In addition, we're kind of on a bit of a urban wildfire interface corridor where a creek comes down and there's riparian zones on both sides. And so, we know from recent years in British Columbia that urban wildfire interface is something of note, and has been on people's radar recently, and rightly so, because of the concerns of forest fires and the increased frequency and intensity of them that we're seeing here in this part of Canada, and elsewhere for that matter. So getting into the project goals, first and foremost for me was really being able to do a deep energy retrofit, being able to reduce the amount of energy that we used in this house by at least 50%. But also part of that was seeing if we could take an existing residential building and meet the newer BC Energy Step Code 5, which is the highest threshold. For those of you that aren't from BC or may not be familiar with the BC Energy Step Code, essentially it's a code that provides an incremental approach to obtaining energy efficient buildings that really go above the base requirements of the previous BC building code, and it provides a pathway to ensuring that all buildings province-wide are net zero ready by 2032 to meet our climate targets. Another part of this, my research, was using modern technology to sort of optimize the deep energy retrofit process. And I'll talk a little bit about that in a minute. Decarbonization was also a priority, and that term basically refers to removing or reducing the amount of carbon dioxide output into the atmosphere. And from a homeowner's perspective, that can be achieved by simply switching from the usage of switching to low carbon energy sources. For us here in BC, it would be switching from natural gas to electricity, and the vast majority of our power comes from hydro. Climate proofing, again, talking about that urban wildfire interface. Passive survivability is really about, can we, use our homes as areas of refuge, sanctuary, when we have these more frequent and intense natural disasters, heat waves, power outages, when we have cold snaps, when we have wildfire smoke. Do we have the ability to stay in our buildings, but also still breathe healthy air? These things are, really important and something we should be thinking about more often. And then, of course, indoor environmental quality as well. And so we spend 90% of our time indoors. It's really important to make sure that we have a healthy environment indoors. And then for my family, it was really about making our forever home. This is a location we really like, and being able to stay here and enjoy it as we age in place, and have it meet our needs was also important. But at the same time, we didn't want to be in a situation where we took a building that actually still had really good bones, and in some cases where people like a location but they don't like the building, they'll just sort of take it all down and leave a smoking crater and send a bunch of that material to our landfills. And we didn't want to do that. We wanted to save as much of the original structure as possible. In that case, it was at least 75% of the original structure was the target. Of course, and then of course there's the larger climate issue, right? So we know that 1/3 of greenhouse gases come from buildings. Most existing buildings that we have here in Canada will still be standing 50 years from now, if not longer. And in my area, we call this low-hanging fruit when it comes to meeting climate targets. Some of the strategies we employed were, let's talk about design teams, making sure that we had an integrated project delivery-ish type technique. And by integrated project delivery, really I'm talking about is everybody that's involved in that process, making sure that the occupants, the designers, the contractors, even the energy advisors, and when possible, some of the more important trades are involved in the conversations at the design level phase. This is your opportunity to recognize synergies, and to reduce some of the inefficiencies of a typical way you deliver a project. And then we use newer technologies. We use a 3D Faro laser scanner. For those of you that aren't familiar with this, think of traditional surveying equipment that you would set up on like a tripod, but in this case, this laser scanner sets up on a tripod and quickly can scan two sides of a building. Within a matter of an hour, you can do a 3D scan of the entire exterior, interior, to within extremely fine tolerances. It shoots 3D points every few millimeters, and then we can quickly export that into a 3D building information model. So right away, you have this great model that's way more accurate than pulling tape. It's in 3D, so you can use 3D software to make changes to that. And it has a huge advantage in terms of when we talk about deep energy retrofits. And so those two things, both 3D laser scanning and building information modeling, while widely used in the commercial building industry, we haven't seen as much application in the residential side, in this case, the deep energy retrofit side, and it has huge promises. And so I was able to take that 3D modeling information and use a sustainability analysis for shading, for lighting, for energy modeling, even for looking at how dominant winds can be captured during the summer for passive cooling techniques. And so it's such a bonus than just sort of kind of speculating on things or not including them in your design aspects. And really I think for the benefit that you receive from that type of approach would far outweigh any type of additional cost. And then, of course, building envelope improvements. This is really kind of where, for me, and I'll stress this for you as well, if you're targeting a deep energy retrofit, should be your priority. And so first and foremost is stopping any type of air leakage. We use smart membranes for air and vapor control. In this case, you see a SIGA product that's on the exterior, that blue that's on the house here on the left. But there's also a SIGA product on the inside of that as well. And those are smart control layers. So They have the ability to make sure the air doesn't leak, but if you have moisture inside your building, then vapor can diffuse through that. And this is really important when we talk about existing buildings because especially residents, some existing walls may already have impermeable vapor layers in them. And so what you don't want to do is trap moisture in your building. You want it to be able to breathe. But yet remain without having any air leakage. We also tried a new technology called aero barrier at mid-construction blower door tests, and you'll see an example of this right here. They set up these basically aerosol emitters when they pressurize the building, and what it does is it goes out and it plugs all these small little holes that you might have in your building envelope that you don't see, you weren't aware of, I think up to a ½ inch in size. And really it can be, when we talk about small holes in building envelope penetrations, it's kind of death by 1,000 cuts if people haven't paid to the attention to the detail. So it's an interesting technology, and I'd like to see it more research on it in terms of existing buildings. They do it quite a bit now in new buildings, specifically when they're having trouble meeting their blower door test requirements. And then also making sure as part of that high performance building envelope that we have a really good window. So we have triple pane fiberglass windows. And then you'll see a picture image up here of we actually blew the roof off this house. And I'm going to get into the fact that you don't have to do this. And to do a deep energy retrofit, again, we had our reasons for it. But I basically specified an open web truss roof system that actually has the ends right back. Some of you may not understand what I'm talking about. Where I'm circling right now basically is where this lands on my top of my wall. I have the ability to run my exterior insulation all the way up past where my roof system meets the top of the wall, and it allows me to have continuity in my insulation layers that are on the outside of my house, achieving this thermal bridge free design. So that may make sense to some of you, that may not to others. That's okay. But nonetheless, I just wanted to point that out. So some other strategies with the building envelope. We use mineral wool, both in terms of cavity insulation, but also in terms of exterior insulation. I love this product. The fact that it's made locally here in BC is a big reason why. It's also a byproduct, and it's nothing, no bugs or termites or anything wants to eat it. It's hydrophobically stable, so it can get wet and dry out and not deteriorate. It's fireproof. You can take a blowtorch to this, and it will take a very extreme long time to burn. And we have 5 inches of this mineral wool board, rigid board on the outside. And in addition to that, in some places we use a sheeting product. We did have an addition, around 300 square feet of addition. And instead of traditional sheeting material, we used this wood fiber sheeting material that's produced in Quebec. And unfortunately, it's the only place in North America that I could find that it's produced. They do produce it in Ireland and Europe, which is funny because it comes from a softwood product, and we in BC are some of the largest softwood areas in the world, yet we don't produce any of this wood fiber sheeting. Just an idea for anybody out there. In addition, as part of that whole resiliency and climate passive survivability, we use metal roofing and cladding on the exterior. All of the exterior cladding is metal. Part of it is because it's fireproof. The other part is we have to use really long fasteners to go through 5 inches of rigid insulation. And we want to make sure that whatever that cladding material is, it's light, so we don't get deflection in those fasteners. Overall, my envelope went from an R12 to somewhere between R30 to into the high R30s, depending on what aspect you're on in the building. Additional strategies when it came to decarbonization and energy efficiency, that was simply switching out my gas equipment. So went from a gas furnace to an air source cold climate heat pump, actually significantly smaller than what you would have to have normally for a house this size. switched over from a gas hot water tank to a domestic hot water pump. All our gas appliances were switched over to electric Energy Star certified electric appliances. Essentially, this home is net zero ready. We're ready to install solar panels after I've had about 2 years of real world operational data. I've got one so far, and we'll be ready to go for that. In terms of indoor environmental quality, it was really important that we maintained healthy air in this building. I chose to install an energy recovery ventilation system, or ERV. Some of you may be familiar with an HRV, heat recovery ventilation system. I'll explain why I chose this in a second. But basically, either one of these systems is a way of getting clean air into your building, exhausting stale air, and maintaining as much of that energy, that conditioned air, as possible. So there's an energy recovery element to it. And of course, whole house HEPA filtration. Now, basically, with my central air system, I've tied on a filtration system that has a HEPA filter rated. It's what you would need to remove, say, the small particulate matter that comes with that wildfire smoke. And so during the summer, we know when it's smoky out, with air quality advisors, they tell us to go indoors, to shut your windows, turn off your HRV or ERV system, because it does bring in smoke. Most of them, there are a few exceptions, don't have the ability to filter it out. And for me, that's not good enough. I want to make sure that we maintain that indoor air quality. And so now I have a HEPA filtration system whole house that I can turn on, filter out that smoke as well, and so maintain good air quality. And of course, you can't do anything about it if you don't monitor it or measure it. And so having a whole house air quality monitoring system was also important to us. And then maximizing daylighting opportunities, really important. And then we also raised the roof on this and created some large open spaces that we didn't have before. And I love, open spaces with high ceilings, but one of my biggest gripes with them is acoustics. And sometimes we just take it for granted, but just, think of some of those great rooms that are just beautiful to look at. But when you have, a number of people having conversations with music, it's very often difficult to maintain a conversation, or there's a lot of noise that makes it difficult, noise pollution to concentrate at times. And so one thing that I'm really happy what turned out is, instead of doing traditional drywall ceiling, we use cedar 1x4s that are produced here in BC with 1/2-inch gaps between them, so a reveal, which is a nice aesthetic look as well. But behind that is a geotextile fabric or acoustic fabric. So that basically functions as a big acoustic diffusion feature in the ceiling. And so instead of having a hard surface on the walls, on the floor, we have the ability to break up those acoustic waves, and does a great job at dampening and making a really pleasant space to be in, even when you host people and have parties. I think it's also good that part of our strategy was keeping focused on the available government grants and rebates and loans. We live in a time actually where we have access to more grants, rebates, and loans when it comes to retrofitting your homes than I believe ever in history. And so being aware of those, understanding when you can start them and that process, and who can actually do the retrofits, if it's something you can do yourself or you have to have a qualified contractor. This is all really important because ultimately, it affects your financial bottom line. And we were able to take advantage of these government grants and loans, totaling close to $50,000. And this is not because I'm special or anything like that. It's just because I made myself apprised of the information and the process. And I know that I'm not the only one that's done this. So getting down to the results. The original target was that deep energy retrofit. And so here we have 2 EnerGuide ratings. You guys that have had an energy advisor come to your house and provide an energy audit should be familiar at least with these 2 ratings at the top. So pre-retrofit, my house used 95 gigajoules a year. And this is for basically 2,285 square feet of floor area. Post retrofit, and this is based on both performance but also prescriptive factors. The performance factor being the air change. So again, pre-retrofit, I was at 4 air changes and 95 gigajoules per year. Post-retrofit, we got that down to 45 gigajoules per year. And what I was really happy with was down to 0.98 air changes per hour. This is great. This was, I was extremely happy with that turnout. Hitting one was, for a existing building, I thought was going to be really challenging, but I think having this process really helped us realize that goal. And I think that we made things more difficult by having more extensive renovations that didn't relate necessarily to the deep energy retrofit. We did add volume. We pushed our roof up, added a new roof. We also had the addition as well. And so we basically left a really kind of ideal shape, that rectangle, and kind of turned it more into an L, which doesn't necessarily make an advantage, right, when you're trying to hit these targets. So we were still able to do that, but even despite increasing volume and changing the shape of the house. But I still wanted to know exactly what it looked like in terms of when occupants were in the building. So that's where your utility bill comes in. I was able to look at utility data from 21, 22, so pre-retrofit. You can see this graph over here for every month in 21, 22. And that basically, we used 78.1 gigajoules per year. And you'll notice that that is lower than what the energy advisor shows. Part of that's because they have someone like me in this house. My kids will tell you that I'm not happy when people leave the lights on and things of that nature. So I'm a little bit probably more diligent than other people, but nonetheless, this is real world data here. And you can see that post retrofit here in orange in 23, 24, that was reduced to 37.9. So that's an actual energy use, real world energy use reduction of 53%. You'll see that my annual utility savings is $1,500. Now, in the end, did I do this to save money on my utilities? Well, partly, yes. But am I going to be able to justify the payback alone for what I did on my particular retrofit? Absolutely not. But it doesn't mean that I couldn't have targeted deep energy retrofit, just focusing on the energy area, and not have done something that was a feasible return on my investment. And I'll talk a little bit about that in cost in 1 second. Other results that I was, really pleased with were things that related to indoor environmental quality. In fact, for me, this is arguably even more important than energy performance. And part of that reason is this is where my family lives. I want them to be in a healthy indoor environment. I just want us to be able to flourish and thrive in this, in our home. And so overall, we monitor our indoor air quality. It has remarkably improved. And there's probably several reasons why. Choice of materials that we use. I think a big part of it is having that whole house air filtration coupled with that air exchange that we have. One thing you'll notice is when we bought this house, we had a radon issue. And if you live in the Okanagan Valley and you have not tested for radon, please do. We actually live in an area that has some high levels of radon. One house may not have much, and the house next door, because it's how radon makes its way to the surface, could be lit up like a Christmas tree. It's something that you don't want to stick your head in the sand about. You want to be aware of. When we moved into this house, we actually had radon levels averaging above 200. 200 is the threshold here in Canada that they've set, in my humble opinion, quite arbitrarily. In the United States, it's 150 is the threshold. In Europe, it's 100, and they're even taking a second look on that. So from a precautionary approach, I just wanted to get that radon level as low as possible. I did some radon mitigation in advance of this pre-retrofit. I managed to get it down to 100. But one thing I was concerned about is when you make your building tighter, when you make your building envelope tighter, you can potentially increase the radon level. But that didn't happen in this case. And I actually reduced by, down to a third of what it was, less than a third. And I think a big part of that was that air balancing with the make up fresh air through the ERV system, which could have been done with an HRV. And that basically balances out a lot of the pressures in your house, so you don't have such extreme pressure differences where it can be the reason why radon makes its way into a home. So getting back to some other environmental quality issues, we actually had a really fairly low average winter humidity in our house. The ideal humidity range in your house should be somewhere between 40 and 50% and should never really go below 30% or above 60%. And so some of you, if during the winter you feel like you have a dry nose or a dry throat at times, that might be because the humidity level is too low for you during the winter. And so through installing an ERV, energy recovery ventilation system, versus an HRV, we were actually able to maintain some of the moisture that we were generating in our building during the winter, which was a good thing in this case. And so that took it from an average of 30% to 45%, which is an ideal place to be as far as I'm concerned. And just, again, adds to the overall indoor environmental quality. Acoustics, there's a notable improvement in our acoustics in this building. And then the one thing that I like to think about too is, we talk about thermal performance of a building, but thermal delight, I think, is a good way of thinking about it. For so long in Canada, North America for that matter, we're content during the winter just to have, cold feet and a hot head because we have so much stratification in the house. That's not a case for us anymore, right? We have no major thermal gradient divisions, and it's just even. It's always within that thermal comfort zone, and you can sit next to windows and read during the winter, and it's just really delightful. Not a better way to describe it. In terms of climate passive survivability or climate proofing, we have a fire resistant envelope that I talked about. But one thing that we did with all that insulation and air sealing is now we have significantly reduced our heating and cooling loads. So that means that during a power outage, we don't have to necessarily worry too much about not being able to stay in our house and be comfortable, whether it's during a heat wave or a cold snap. And we additionally have a backup high performance wood burning stove as well. But I do want to mention that in a high performance house like this, the first time you do light up a wood burning stove, just make sure that you're going to have to open some windows. It got hot in here when we tested it out. Some other benefits, we actually hit that 75% target of obtaining the original structure. So almost 80% of the original structure, believe it or not, is still here. A lot of people walk by this house nowadays and they think that somebody from Vancouver bought the house, blew it up, and just put a new house there, but that's not the case. And then by doing so, we avoided a ton of embodied emissions that you would get versus, by doing this retrofit versus a new build. There's biophilic design elements I talked about. There's lots of wood. There's connection to outdoor spaces. We have really good viewscapes now into, flora and fauna and riparian zone and that park area before that we didn't necessarily have before in the old building. Exterior noise pollution has dramatically reduced. We used to hear people walking on the path at night and getting up to whatever, and now there could be a train wreck outside if we had trains there, and we probably wouldn't even hear it. And then, of course, there's always the benefit of increased market value when you do changes like this as well. So, a project like this does not come with lessons learned. And so these are some takeaways that I have from this project. And one of those is existing buildings may not meet current building code requirements, right? So when this house was built in the 50s, the setback limits between buildings or limiting distance between openings of buildings, these things weren't necessarily in place, or at least as stringent as they are now. So that's something to keep in mind. And we had some challenges along with it. But I find that if you start conversations early and often with code officials, they're excited that you're doing projects like this. They want to help you if they can. Part of them being able to help you is, again, having those early conversations, not taking an adversarial approach either. Consider them a member of your team, And then you doing the homework as well, understanding the intent of code. Because often when a building code official feels like they have to, basically tell you something, contrary to what you'd like to hear about, if you can prove that you're meeting the intent of the code, then often there is some daylight. And this happened quite a bit where I had a building code official that was happy to kick it up to the next level building code official. And we didn't always, come eye to eye on some things, but for the most part, I was able to, to navigate that by doing, my homework, to familiarizing myself with what aspects of the code they were concerned with. Another important aspect is deep energy retrofits are not standardized yet, and budget contingencies need to account for this. So with new home construction, often they tend to tell you to have a 10 to 15% contingency. Well, when it comes to retrofits, I would say that you need to be a little bit more braced for some higher contingencies. Again, because these aren't standardized processes yet. In some places like Europe, they do have some standardized practices that I would love to see more uptake for here in North America. We'll get there, we're just not there yet. And then also you need to think about these deep energy retrofit projects as an opportunity to educate, bringing trades and contractors along with you. I held multiple workshops on site where we showed some of the trades how to properly install windows into the building envelope, so we didn't have air leakage, and as well as electricians and HVAC installers to make sure when they had to put penetrations in our building that they were properly being sealed. And then, of course, another thing to think about is, deep energy retrofits, they're scalable up or down. And depending on, what your goals are with your retrofit project, it's actually, you can do a deep energy retrofit for significantly less than what I did. So on that note, let's go ahead and get into the cost. That seemed to be the number one issue that people wanted to hear about. Before I turn over to the next slide, again, this is for what we did with this project. Not everything we did was based on energy efficiency, and if it had been, it would have been significantly cheaper to do so. So one thing I'd like to say also is timing is everything. And so I did this project as part of a sabbatical. And from the time I found out that I was awarded my sabbatical till I needed to basically start design was only a few weeks. And so things had to happen quite quickly for me. In hindsight, I would have loved to have had more time, but I only had about a year to implement this project. And so the original cost estimate that we had, myself alongside with a colleague of mine that is actually has a design build firm and teaches estimating in our program, came up with $270,000. Unfortunately, any of you that were involved that know about what happened in the first half of 2022 was probably the worst time to be in the construction industry or in terms of sourcing materials and pricing, because we found that across the board, construction material costs went up 30% in 6 months. And that I was not prepared for. And not only that, but there was significant supply and demand chain issues. And so I was constantly finding myself having to pivot to different options or materials that often came at a higher cost or premium because they were the only things that were available. And some of the approaches that I wanted to do with my project, I was unable to do as well. But I will talk about some of those things that could have reduced the cost. And ultimately, the actual materials and labor cost came to $360,000. That doesn't include any of the grants or government retrofit loans that I talked about. Renovation area cost for the cost per square foot for the area that we renovated, not the addition. It came out to around $118 per square foot. Of course, with addition, those costs go up. And so for the 300 square feet or so that we had, that portion was around 282 square feet. And so that may sound like a lot, but for those of you that have been quoted a price to build a brand new home to meet just step code 3, you're looking at anywhere from $350 to $450, excuse me, per square foot. So it was significantly cheaper, I can say, for us to do what we did than build new. And then of course we were able to leverage some grants both provincially and federally, as well as that federal Greener Homes grant. And then of course, looking back in hindsight, there was always opportunities to save in hindsight. And one thing that an electrician apprised me of about, and I think someone mentioned in their comments, was just the cost that you're to upgrade your panel. Most of our electric panels are 100 amp in older homes. When you look at installing heat pumps or other electrical equipment that take higher amperage draws, then you're often required to bump that up to 200 amps, which gets expensive because you have to go underground with that. With the service line, you have to upgrade your panel, and that can cost anywhere from $8,000 to $12,000. Mine was probably right around $8,000 to $9,000 because I was able to do some of the excavation work myself. But I learned out later on there are things like load sharing and circuits and smart panels that actually have the ability to decide what circuits get priority. And this is interesting because they did a study in California, Pacific Energy, and they said that 99% of residential homes in California can work on 100 amp services. And so that's just using smart technology to prioritize, making the difference of, say, if you plug in your electric car and you turn on your dryer, then that circuit will recognize that and switch to the dryer and stop charging your car momentarily. Similar thing happens with the smart panel. And so just being aware there are options for that. Also going on a watt diet. And by that, I mean, you can choose mechanical or HVAC improvements that don't draw a lot of amperage. They make a 120 volt domestic hot water heat pump instead of and that's only a 15 amp circuit versus, say, one that takes a 30 amp circuit. So I think doing your homework there can help. I think being creative about how you source some of your mechanical equipment. One thing I've noticed here in BC is the cost of installing heat pumps has gone quite high. And so one thing just in my case was that, the actual material, the heat pump itself, and all the everything I needed to connect to my central air, that material in itself, the cost was around $7,000. But by the time you added on labor and all their other costs, I was around $26,000. I've heard of stories of people actually sourcing their heat pump themselves and then paying an HVAC installer to install that equipment, and it still meets the warranty. But you just have to find an HVAC contractor who's willing to install equipment that he didn't source. In other words, don't get fleeced. And then, of course, one thing I wanted to do was a panelized retrofit jacket that I didn't get to do because of my timing. And by this, I mean in Europe, and they're starting to do it now in Canada. There are companies that are developing these panelized retrofit jackets that include your air and vapor control layers, as well as your insulation layers. And they basically slap them up on the side of your house. And it's kind of like wrapping your house in a sleeping bag. And to make an easy example. And I really wanted to do this, but all the panelized companies that I contacted in BC at the time were having the same difficulty, supply chain, and they basically told me that I was looking at a year wait before I can get what I needed. So it wasn't an option for me. So we pivoted. The other thing is retrofits often can be timed where you have to make necessary repairs anyways. We call these triggers. So an example of that is it's time to change out your roofing material or your cladding, and the cost of adding additional insulation when you already have a time necessary repair or replacement is really nominal. It's not a major expense compared to something you're already having to do. And then I also want to point out that if we didn't do everything that we did to our particular project, say if we just focused on the deep energy retrofit alone, in this case, the envelope, right? So that's the walls and the roof and the windows. making sure they're high performance insulated and they have really, really good air control and vapor control layers, plus the ERV, because once you make your building envelope really tight, you need to have that fresh air makeup. That cost alone would have only been $81,000, right? If we wanted to look at another option where we thought about decarbonization in addition to the deep energy retrofit, the mechanical, electrical, and plumbing upgrades would have added an additional $50,000 to that at $131,000. So it really comes down to, what are your priorities? It's when you're doing a renovation, I think it's important to, to know that it's, you have an opportunity, and it's tempting to include other renovations, and sometimes, you should. And home upgrades, they are, they're not always energy efficient related. Maybe you included an addition like we did, or decide you want a kitchen renovation. I think it's important that that your deep retrofit can be a great opportunity to make your house into your dream home. But every upgrade, and this is worth noting, or renovation is going to increase the overall cost. And this can lead to serious sticker shock when you get the work quoted. So I guess the takeaway here is if the deep energy retrofit is your focus, then you can do it for significantly less than what we did. So I guess the next thing I noticed in terms of the comments was people are kind of confused on how do you start this process. It seems like a lot of information. It can be overwhelming. And luckily here in BC, we have energy advisors, and you can call them up. There's several firms that operate throughout the Okanagan and throughout BC, and actually in Canada for that matter. They have the equivalent in the United States as well, and they'll come to your house and they'll basically go through and they'll do a blower door test. They'll tell you where your house is leaking. They'll give you a report and basically kind of outline what are the priorities. What are you going to get the most bang for your buck in terms of where you put your money to make your house more energy efficient. But taking a step back from that, I always like to advocate for a whole systems thinking approach, whether it's a new building or existing building. And that really starts with basic building design. And in that case, that's where we prioritize things like, insulation and making sure that we have a building envelope that doesn't leak where it shouldn't. And looking at all those passive components as well. Where can we get natural lighting from so we don't have to use daylighting? Can we utilize these windows for nighttime cooling? So in the morning, mid-morning, we can shut our windows during the summer and our buildings stay cooler without air conditioning longer. These are low-hanging fruit, and often they are really no cost. It's just decisions that you make in this process. And then, of course, the very last thing that we should really be looking at are our active energy components. In this diagram here, they're shown as tier 3, and that's like mechanical equipment. So if you make your building as airtight and as insulated as much as you can, then your heating and your cooling equipment can be downsized. And through the life cycle of a building, these are the things that we often have to replace more. I have the highest life cycle operation cost for maintenance and replacement. And the smaller you can make that, the lower that life cycle cost is. Plus, the smaller your heating and cooling equipment is, that just means when you don't have access to power in a power outage, then your building has some passive survivability built into it as well. Along with those active energy components are also solar panels. If I would try to get to net zero with my house without doing any renovations by just slapping solar panels all over the place, I wouldn't have had enough room on my roof to begin with. Not to mention I would have had to mount 2 ground mount tracking arrays, basically taking away most of my existing yard. And so now that I've done all this work, I've actually reduced that the amount of power that I need to generate on site to get to net zero or net positive by more than half. So just by taking this kind of whole systems thinking approach. And then, of course, again, being aware of what potential financing looks like, right? So there's the Canadian Greener Homes Loan. There used to be the grant. I don't believe that's in existence anymore. There's Clean BC, which operates through Fortis BC, Hydro BC. There are locally municipal programs as well. And then, of course, timing with triggers. I think it's also worth noting that deep energy retrofits can come with a hefty price tag, right? Let's just face it. And that depends on several factors. And while there are several benefits of going all in at once, like we did, you can actually spread these costs out over time with a staggered retrofit approach. But you need to have a plan to get your home to that deep energy or net zero ready mark, and make sure your upgrades work together as a whole system and fit with your overall goal. If you start with mechanical, that just means that you have to size equipment to basically condition or heat the house that hasn't had any changes to the cooling or heating loads. So it's going to be larger size equipment, and it's going to basically cost you more to replace it. And then when you go and make replacements to upgrade your envelope, then that equipment is probably oversized. So having a planned approach, if you're going to phase it, is really important. And then, of course, finally, a deep energy retrofit, done right, has many benefits that I've tried to highlight tonight. And in my opinion, are just as important as just the energy saving, if not more. When you consider these benefits along with your total cost of ownership and the fact that a deep retrofit is a practical way to take climate action, improve indoor environmental quality, climate passive survivability or durability, retrofitting your home is absolutely worth it, in my humble opinion. Thank you. And I think I can probably take some questions there.
Well, we do have a number of questions in chat. Some of them are very specific to people's situation that may not be germane to other people, but we'll try and get through some of them. Suzanne, who lives in a condominium, is asking if you can insulate from the inside if you're in a situation.
Yeah. So, condominiums have strata agreements. So I think you have to basically check with your strata first, but insulating from the inside, we did that in our home. In fact, actually, we found some walls in our home that had no insulation whatsoever. It was interesting after the fact. So if you have some older homes, sometimes you'll find that they may have newspaper in them.
Right. Someone has asked, what about using ICF foundations, insulated concrete forms? Had you thought of that?
Yeah, no, I mean, ICFs right now, as far as off-the-shelf available technology, are really a great way to go if you're going to be doing an addition. In this case, I didn't use that. I use what we call sonotubes. So my addition actually is above the ground, and it sits on sonotubes, these kind of round concrete pillars, because I didn't want to have a big impact excavating. We kind of live in a riparian zone. And so I try to keep my impact low. Plus, actually, it ended up being cheaper. And I just had a super insulated floor system. It's like an R55 floor that my addition sits on. But again, if you're building a foundation aspect or renovating, you have an addition, ICFs, are a good way to go. I don't like the fact that they rely so much on rigid foam because they have high embodied carbon. But really, at the moment, there's not a lot of off-the-shelf available alternatives.
Okay, thank you. And another question, can you use aero barrier only if you have an empty building?
No, actually, this is funny because we actually lived in this renovation throughout, believe it or not, which is crazy when you see some of these pictures like this. And so we actually, I had the basement finished for the most part before I got into the superstructure, everything above ground. And so that's kind of where we lived throughout this. And believe it or not, I'm still married. So that's a true test of a marriage, also as a side note. And yeah, so yes, you can, I'm sorry, maybe I lost track of that question.
It was about, I think I've lost track too, actually.
Okay.
Because I'm looking at, was that
air barrier?
Air barrier. So yes, we had air barrier actually come in while we were living in the house. We just had to isolate the first floor from the basement area. So Yes, it can be done in renovations. In fact, this was part of I think around it was 10 retrofit projects that were demonstration projects to see if aero barrier could be used. Yeah, so yes.
Okay, and several people have pointed out that radon testers are available from many local libraries, as are heat cameras, so that you can have a look at where you need insulation. So it's called Library of Things, and most libraries are starting to get these two things. So check it out.
Great. Thanks for pointing that out.
Another someone, Sue, is asking, are HRV and ERV systems expensive to install?
Yeah, so my system ended up costing around, I believe around $4,000 to install onto an existing into an existing central air handling system. That's, I think, a little bit on the higher side. What's nice for retrofits is they make HRVs and ERV systems that are designed for retrofit applications where they punch a hole, actually two holes, 6-inch in diameter on one side of a building. And then they punch a hole through another side, and it basically has a ceramic core to exchange energy. This is called a Lunos, and I believe they're ERV. I'll just post that for everybody, and you can take a look at that. And I think those systems, I haven't checked the price for a while, but I think to get two of those, it was a little bit under 2,000 last time I checked, which might have been 3 years ago. So
someone was asking whether, Catherine, whether you considered using hemp instead of the wood fiber sheathing. Have you heard of that?
yeah, yeah, I know. Yeah, hempcrete's a great product. Actually love it. If I was to build brand new, I would have actually used this product called biofiber, which are these hemp blocks, but it wasn't practical for this renovation aspect, and I actually couldn't get my hands on them. But the wood sheeting, the reason why I was able to use that is it takes the place of other sheeting materials like OSB or plywood, which you're required to have over your wood framing. It's a structural element. And so they don't make a hemp product that I'm aware of that will meet the sheeting requirements. But it's a great product if you in other formats.
Thank you. And Ruth is asking, where can we get smart panels?
Where can you get smart panels? Is that the question?
Yes, that's correct.
Yeah, no, that's a really good question. I didn't get one. I only had this conversation after the fact. So I believe they're available in Canada. I mean, I think there's going to be a price premium for a smart panel versus a standard 200 amp panel. But it saves you the cost of having to go through everything that's involved with upgrading to a typical 200 amp service.
Great, thank you. And now, there's a few people asking specific questions. Someone's asking about a list of your contractors. Perhaps could people submit questions to you by email, or we could collect questions and send them to you in a lump? Would you be agreeable to further few, especially someone who's interested in the contractors, in sharing who those
Yeah,
are?
I have no problem sharing information, but I think maybe it'd be best if you guys collect and maybe you can kind of sort through, because there might be some more questions. I don't want to take any time away from responding to emergency emails from my students. So if you guys could sort of solidify that for me, that would be great.
Yeah, so we'll be sending out an email with the video tomorrow, and people could respond with additional questions that we would batch. Yeah, but thank you.
Yeah, and just based on the number of participants, maybe this is a topic that could be presented in person as well on campus here in the near future too. Just so just keep that in mind. Maybe I can arrange something.
Great, that would be wonderful. Obviously, there's a great deal of interest in that. I'm going to pass things back over to Sue, just to thank you and to talk a little bit about upcoming events with First Things First Okanagan.
Thank you so much, Brian. That was fantastic. I learned a ton. Just briefly, a couple of upcoming events. Our next deep dive will be about the dual impact of climate change and current forestry practices on communities and on their watersheds. And that will be Thursday, November 21st, same time, same place. You can receive a notification if you're subscribed to our newsletter, or you can check out our website early in November, and we'll have the information posted there. First things first is currently involved in another BC Utilities Commission proceeding. Some of you may know we intervened in one last year. This time, Fortis is wanting to build a small LNG storage facility in Kelowna and truck LNG up from the coast. And we believe that this is unnecessary, an unnecessary expense, and an unnecessary danger. Instead, Fortis could meet the shortfall by working with the City of Kelowna to promote electrification of homes and businesses. So if you'd like to learn more about it, we'll send you a link in the email, and you can check it out. There is an opportunity to make a comment to the BC Utilities Commission before October 31st. That's the deadline. So if anyone's interested, we'd appreciate that, because the comments from people about what they think about a project, they do help us with our case. And I think that's it for the next little while that's coming up. So hope to see you again next month. And thanks again for coming, everybody.
And thanks to Brian for such a well-organized presentation with just a ton of information. I know I'll be looking at the video again just to sort of, I just had the information wash over me the first time, but I'll be absorbing it the second time. So thank you, Brian.
Have a good night, everyone.
Great. Good night.
Good night.